Okay, so I'm going to set up the experimental setup. The first thing I need to do is place this square mass 15 centimeters away from the center of the rotating platform. This is the center, so this is 15 centimeter position right here. So I have to put this square mass at that position. So I don't know what is the center of this square mass. Let's find that out. So the width of this is a square mass, so the one base is length is 0 here, yep, 0 here, and this is 4.4. This is 4.4 centimeters, so the half of that is 2.2 centimeters. So I'm going to put this mass around 15, and this right edge, it is aligned with 17.2. That's guaranteed the center of the square mass at 15 centimeter position. Now I have to secure this. Okay, now the mass is secured at 15 centimeter position. Now I need to connect the photo gate pulley system to the PASCO interface. So now you can see the wire is connected to the digital input 1 of the PASCO 850 universal interface, and I'm going to connect this photo gate pulley system to this base here, like this. Now you can secure that using this screw. Okay, this is the next step. Now you can see this is my step pulley. It has 3 steps, 1, 2, 3. The radius of the step decreases as you go up. So this is the diameter of the largest pulley, the second largest, and this is the smallest one. Now this string is attached to the smallest one, and the string is going over the pulley with 10 spokes. You can see the whole setup. The steps pulleys, the string is attached to the topmost one, and that string is going over the 10 spoke pulley, which is attached to this photo gate. So we can use the photo gate to measure the velocity of the speed of the pulley, and that the string which is going over the pulley is now attached to the mass hanger. Mass of the mass hanger is 100 grams. To record the data, we're going to use PASCO Capstan, and this is the PASCO Capstan software. I already opened the software, and the first thing I need to do is connect the photo gate pulley system to the software. I need to connect it virtually. So to do that, just go to the hardware setup, and here you can see the virtual 850 universal interface. Click on the digital input 1, then from the drop down menu you can select the photo gate with pulley. Now the second thing I need to do is the timer setup. So I'm going to use pre-configured timer, photo gate in channel 1. The type is photo gate with pulley. So I'm going to get the position, linear speed, linear acceleration, angle or angular position, angular speed, and angular acceleration. So those are the data we're going to get using that photo gate or photo gate with pulley. and then I have to configure these parameters of the timer. The spoke length is 0.015 meters and the spoke angle is 36. There are 10 spokes, 360 by 1036. So I'm going to use these default values. So we have all the values selected, and now you can click on the time setup one more time to close the window. And finally I'm going to change the sampling rate. So go here and change it to 100. Now the sampling rate is 100. Now everything is set up. So we have 100 gram mass hanger attached to the string. So I'm going to put 2 more weights. So altogether now it's going to be 300 grams. 100, 100, 200, and mass hanger is 100, altogether 300 grams. Okay, now in order to see our data, I'm going to get 2 graphs. Graph 1, go there, go to that panel, and you can drag and drop there. So that's graph 1, that's graph 2. So the first graph going to be position, linear position as function of time. The second graph going to be linear speed as a function of time. Now I want to compare the linear position with the angular position, or position with the angles. To do that, I can use this tool right there. It is called add new plot area to the graph display. Click on that. Now you have position, and this is going to be angular position. Now you have position and angle graph as a function of time. Both graphs share the same x-axis, time axis. Similarly, I'm going to get another graph, linear speed and angular speed. So I have linear speed and angular speed graphs, and they share the same time axis. So I can compare position and angle at different time values. Similarly, I can compare the angular speed and linear speed at different time values. Okay, now I can collect the data. Now I'm ready to get the first set of data for the activity 1. Now you can see the mass hanger is very close to the Portogate pulley system, and this platform is stationary. Why? Because I'm holding that. If I let it go, it will rotate because this hanging mass exert a force on the string, and that string exert a torque on the rotating platform, so they will rotate. Okay, so I'm going to start recording data. Go to the Vasco and hit record. At the same time, I'm going to release this from the rest. So now it's going down, and I can see some data in my graph, and I need to stop recording before it hit the ground. So let's stop. Now I have my data. So I'm going to enlarge, or I'm going to use this button to see enlarge display or visual of the data set. I have my data. Now in order to compare the position an angle, I'm going to use this tool. It is called add a coordinate tool. If you click on that one, you will see add multiple coordinate tool. So I'm going to use that. So click on that, and now you can see the angle and position at the same time value. Now for example, the time value is 7.477. At that time value, you have your angular position and the linear position. Similarly, I can get angle and position at different time values. Similarly, I'm going to compare the linear speed with the angular speed. To do that, go to the this tool, add a coordinate tool, click on that and get this add multiple coordinates tool. Now you can compare the angular speed and linear speed at different time values. So when you see the data table, you will have angle and position, angular speed and linear speed at different time values. What I'm going to do is I'm going to choose this 5th data point and get the reading, and 10th data point, get the reading, and we'll go up to 30th data point instead of 5 data points. So you will have all the data you need for the analysis.